Alright, hello everyone. So for our SBAC review for today, we're going to go over a few things. So the first concept we're going to go over is distributive property, and this is something that you learned earlier in the year. So it's good to just review it so that we just get a good reminder of what it is, and it does pop up a lot at the SBAC. So what will happen is you'll see expressions will ask you, and some of the questions will ask, find the equivalent expressions that are equivalent to this expression. So something like this, we have 56y plus 32, and on the SBAC they may have a question asking what are some equivalent expressions to 56y plus 32. So to find that, we need to simplify this and turn it into an expression where we can use a distributive property. So to do that, we need to break this down, and we need to find the greatest common factor, or GCF, of 56 and 32, so that we can turn our expression into one of the expressions that has a number outside of the parentheses, if that makes any sense. But, well, you'll see. Okay, so we need to find the greatest common factor of 56 and 32. So to do that, we need to list off the factors of each of these numbers. So for 56, because I know my math facts, and I know most of you do as well, I know that both of them have a factor of 2, but that's not the greatest common factor. I know that they both have a factor of 4. I know that 56 has a factor of 7, and 32 has a factor of 8, which I know 56 also has. So based just on looking at this, I know that my greatest common factor for 56 and 32 is 8, because these are both divisible by 8, and they both have those factors. So that's the greatest common factor. So now that we know that this is our greatest common factor, we can put 8 here, and now we open up our parentheses, and we just need to put, so we know it's 56y plus 32, then we just gotta factor out the 8. So if we factor out 8 out of 56, it'll be 7y plus, factor out 8 from 32, it'll be 4. So that is our expression that is equivalent to 56y plus 32. These two expressions are equivalent to each other, because if you see, when we factor out the 8, we have 7y plus 4, and then if we distribute it again, it will also equal out to, again, 56y plus 32. Now, what if we see an expression like this? Now, for this one is much easier. We don't have to find the common factors. All we have to do is just distribute this number into the numbers that are inside the parentheses. And that's why it's called a distributive property. You're distributing this number so to multiply inside the numbers inside the parentheses. You're distributing it to the other numbers. So 2 times 6k, so I'm just going to draw arrows here so you can see what I'm doing here. 2 times 6k is going to be 12k, and 2 times 2 is going to be 4. So we just put 12k plus 4, and that is the equivalent expression to 2 times 6k plus 2, and that's our equivalent expression. Okay, so we're also going to go over some order of operations and algebraic expressions. So when looking at this expression, 3 to the 3rd power times y to the 2nd power minus 8 divided by 4 when y equals 7. Okay, so there's a lot of things going on here. So first we have an algebraic expression, and we have a variable here, but they tell us what the variable is going to be. The variable is going to be 7. So we just need to replace this variable with this number. So it's going to be 3 to the 3rd power times 7 to the 2nd power minus 8 divided by 4. Okay, so that's going to be our expression. Okay, so before we dive into this expression, I want us to go over order of operations because there are a lot of operations going on in this expression. So I want you to write out PEMDAS or PEMDAS, which stands for, that is the order of operations that you have to follow every single time. Any expression in math, you're going to follow that order, and you're always moving from left to right. Okay, and if you forgot what PEMDAS stands for, it's P is for parentheses. So whatever's in the parentheses you must do first. E is for exponents, then you gotta do the exponents next. Then if you notice I put MD and AS in the same line because, so multiplication and division, or addition or subtraction. And the reason why I put or is whatever occurs first from left to right. So if you see division first, on if division is on the left side and you're moving from left to right, and if you see division first, then you have to do that one first, not the multiplication first. And same thing with addition or subtraction. So they're interchangeable, whatever comes first from left to right. Okay, so now that we've reviewed what PEMDAS is, we can move on with this expression. So we don't see any parentheses, but there are some exponents. So also a quick review on exponents. So what I'm noticing is that when a lot of you see an exponent, you see 3 to the third power or 7 to the second power, you think automatically, oh, okay, so that's 3 times 3. No, that is not what they're asking you to do when it's for exponents. Exponents is a repeated operation. So 3 to the third power is actually 3 times 3 times 3. So it's 3 multiplied by 3 multiplied by 3. It's 3 repeating 3 times. And for 7 to the second power, it's 7 times 7, because you have 7 to the second power. So it's 7 times 7, not 7 times 2. Okay, it's not, when you see the to the second power, it's not multiply that number by 2. It is, you're repeating that number twice. So it's 7 times 7. And the same thing here. You're repeating 3 times. So 3 times 3 times 3. Okay, so for this one, and remember, and if you notice, I'm moving from left to right. So 3 times 3 is 9 times 3, which equals 27. 7 times 7 over here equals 49. So now we've moved on and we simplified our expression even more. So now we have 27 times 49 minus 8 divided by 4. Okay, so now that we have that done, and so now moving from left to right, I do see that we have some multiplication here. And this is the point in the SBAC, if you see an expression like this, if the calculator is available, definitely use that calculator so you don't make a computation error for something that has a calculator available to it. So at this point, this is where I would use the calculator and say 27 times 49. Okay, so that is going to be 1,323. And then we bring down minus 8 divided by 4. And I am totally running out of room, so I'm going to write it over here on this side. Okay, so we have these numbers. Now, I know a lot of you think, so for some of you, your first instinct might be, okay, so now I got to subtract 1,323 minus 8. No, because if you look at PEMDAS again, you have to do your multiplication and division operations before you do your addition and subtraction operation. So even though we are still moving from left to right, this takes priority. We have to do this first. So 8 divided by 4 is 2. Now we got to bring all of this down. So 1,323 minus 2. And 123 minus 2 equals 1,321. And that's how we get to that answer. I know it's a lot of steps, and we have to figure out and remember the order of operations, but if you do the order of operations correctly and you do your exponents correctly, you'll get to the correct answer. So I cannot stress this enough though. For exponents, please remember it is not the base times the exponent So it's not 7 times 2, which would equal 14. It's 7 times 7. So whatever this exponent is, that is how many times you are repeating that that number in multiplication. So 3 to the third power is equal to 3 times 3 times 3. 7 to the second power is 7 times 7. Okay, not 7 times 2, not 3 times 3. It is 3 times 3 times 3. 7 to the second power is 7 times 7. Okay.